So in this lecture again we will learn the pin function. So as discussed previously, NMI is a non-maskable interrupt pin. So NMI is a non-maskable interrupt pin. So whenever we want to create an interrupt, we should not disturb the functionality of the processor. At that time NMI is used. Otherwise interrupt is used. So which is a maskable interrupt. Then test pin, so whenever the test pin is low, so when the higher speed processor has to communicate with lower speed devices. For example, we are connecting speakers or microphones with our device, and our PC is microprocessor is again here we are having microprocessor based our systems, and which are operating at very high speed, and the other peripherals are operating at a very low speed. So for that purpose, whenever there is a communication has to be done, at that time the signals are used, like the test signals are used, ready signals are used. So this is used whenever the communication is there with the lower speed devices. So whenever a low signal at this pin occurs, then processing inside the processor continues, and at against in case of high signal, the processor has to wait for the disabling of this pin. So we have to wait until the operation is completed. Then interrupt request pin. So this is a very important pin. This is a hardware interrupt. So as we will learn interrupt structure in the next upcoming lecture. So at that time we will discuss it more. So INTR stands for interrupt request. So we this here we can connect the hardware interrupt with the processor. Again, ready pin. Ready pins are again used for the peripheral devices to show the readiness of the next operation, for to read the data from buffer or write the data to the buffer. So if we want to read the byte, then previous whole byte reading is completed, or transmission is completed. Okay, so this is the read pin. Reset pin, we know it is common pin for all processors. Whenever we want to start new with the new operations, at that time reset pin is used. So the next, now these are the common pins. Now next are the pins which are specific to the minimum mode. Okay, so as we learn here, there is an interrupt request pin. So whenever INTR pin is generated, in response to the interrupt, there is an interrupt acknowledgement. That processor has acknowledged this interrupt. Okay, so that is a response. So whenever this is a request, this is the from other device, and in response the processor will issue this interrupt acknowledgement pin. So whenever an interrupt signal is generated, the microprocessor generates INTS signal as a response to the interrupt. Okay, now next is a address latch enable pin. As we know that address upper 16 bit, that is 80 to 8015s are common, multiplex address and data lines. So whenever the address is available on the address line, ALE will be high or enabled. And when the data is available on the data line, the DNE will be high. So these are the indication that when the address is there on the pins and when the data is there on the page. The next pin is transfer or receive. Okay, so transmission or reception, data transmission or reception. So whenever the data is getting transmitted, at that time pin is high, and when the data is received, the pin will be low. So it indicates the data is transmitted or received. Then memory or input output operation. So it indicates, this pin indicates that the operation which is currently going on is memory related operation, that is internal memory is read or write, or IO is read or write. So this is indicated by this pin. Then write bar. Okay, write bar operation is whenever read bar we have discussed previously to read the content. Same way, write bar is issued to write the content. In the upcoming lectures, we are going to learn the machine cycle. So at that machine cycle, we will learn this in detail about the writing and reading of the data. Okay, now next is a hold pin. Whenever external devices enables this pin, the processor stops processing the buses immediately. Holding is done. Okay, for the recent task is get over. Now, for example, as we know that whenever something is going on, okay, previous operation. For example, this is done in case of the memory to memory write operation. I will give one example over here. When you are writing, you are transferring the data from CD drive. Okay, CD, we are using CDs and CDs for transferring the data. So whenever we are writing the some content from CD to the memory or from memory to the CD, at that time there is no interference or there is no work of processor, but our address and data lines are used in this operation. Okay, so at that time hold pins are used. Okay, you should know that no, don't continue with the regular operation. Hold or wait for some time. Okay, hold and hold acknowledgement. So same way as we learn that
मम्मी तुम्ही चॉकलेटी कलरचे पिन आणलेले बघ त्याला
hello. So there is a hold acknowledgement. Okay, so the hold acknowledgement is the next pin. So these are the pins which are used for minimum mode. Okay, now pins used for maximum mode. So these are the last pins. Okay, now these are the last pins. So pins used in maximum mode. As we know, I have already explained the instruction queue and related with